you comfortable? You have to go to the washroom or anything.
You still get calls.
Yeah, go ahead and lean forward for me as far as you can go. Good.
Does it help if I hold on to you?
That's fine.
Yeah, that'd be good. All right, just like last time, there's going to be a little bit of a pinch and a burn here, okay? That's the numbing medicine. When you feel the pinch, don't move. How many years have you been an electrician for?
Oh, 40-something.
In this kind of study, what we're doing is we're having people who have Alzheimer's disease, they come into the study, and they have this spinal catheter placed so that we can sample cerebrospinal fluid once an hour for 36 hours. And the purpose of measuring all these samples over all those hours is to get a measurement of the speed at which amyloid beta is produced by the brain and how quickly that amyloid beta is cleared away. Cerebrospinal fluid. This is the stuff that surrounds your brain and your spinal cord, flows through. You know you make 20 mils of this an hour, every hour of your life?
Isn't it?
Yeah. It's very difficult to get access to a human brain, and so one key access we have to it is the cerebrospinal fluid. This fluid reflects what's going on in the brain, and that's where the amyloid beta ends up. So we're going to be analyzing that very carefully. Why is this amyloid beta depositing in these sticky amyloid plaques and doing damage to the neurons? Why is it killing the neurons off and destroying the synapses? Now, what's recently been discovered is that the protein where amyloid beta comes from exists in neurons, mostly at the synapses where it's cut. It's possible that when the neuron fires at the synapse to communicate with its neighboring neuron, it's producing more beta amyloid. And so neurons fire anywhere from 1 up to 100 times a second. And so every second that that neuron's alive, it's producing packets, amounts of this beta amyloid into the outside space of that neuron. Young, healthy people produce and clear up their amyloid beta. In Alzheimer's disease, we think something goes awry. We think either they're producing too much of this beta amyloid or they're clearing it away too slowly so that those processes are now out of balance. If it's not cleared away, this beta amyloid builds up into the larger structures that we call the amyloid beta plaques that appears to be toxic to neurons and synapses. And you can see here, these neurons get sicker and sicker. They lose connections to each other so that they can't communicate anymore. And eventually, these neurons will die. And when enough neurons die and enough synapses are lost in the brain, that leads to the clinical symptoms of dementia and Alzheimer's disease. See how the catheter's doing? Anything we can do to lower down the levels of amyloid beta, we think is likely to help Alzheimer's disease. And that's why targeting this beta amyloid and lowering down its production is a key step towards the treatment of Alzheimer's disease. From the days of Shakespeare and before, senility has been well described. It's throughout history. And for the first time, we actually, most of us think that we have a good